So today we are going to cover about understanding the in the Hibernate itself. These are the topics we're going to cover, like understand the differences between components and entities. All this while we saw entities, like each and every Pojo that is mapped to database is called an entity. So we're going to see what are the components within an entity and what is the difference between an entity and a component. Walk through some uses of components and their mappings and look at different strategies and implementations for realizing the inheritance. Objects is nothing but inheritance, right? So from the same table you can map to various objects, and how inheritance can work is what we are going to see. Okay. So what is a component? As we discussed in UML modeling of composition, that is whole part relationship. That means a part of the whole cannot exist without actually having a parent available. That means the life of it is same as the parent. That is called composition. Um, it's like a has a relationship. Like account owner has an address. It's like a whole part relationship, and address has no meaning when it is not associated to account owner. That's the idea here. Okay, then let's see how it is. Okay, now look at the difference between what is an entity and what is a component. First, let's talk about an entity. Entity is nothing but first class citizen, lives on its own. That means, say for example, in our account owner object. In our account owner object, this is called first class citizen. The reason being, it's in its own class file, and this is directly mapped to a database table. Like if you see our lecture 1 database, it is directly mapped to account owner. So that's why it is called first class citizen. Okay. First class citizen and lives on its own. And then entity has its own table and identifier, just like how we saw just now with the account owner. Can be made up of multiple components. That means entity has different components. And now look at the with this definition in mind. So say for example, address is a component. That means account owner is made up of multiple components, like set of accounts, address. So that means this is a component. Address is nothing but a list of fields. If you go to address, it has what? Again, it is associated to account owner and street address, city, state, zip code. So that means it is actually covering bunch of columns. Say for example, your table has, if you look at your account owner table, you have account owner ID, last name, first name, social security number, street address. You have street address, city, state, zip code. So all these address, city, state, and zip code stuff is all gathered together, and we put it in a component. Okay, so that means so this particular object is taking care of all these fields: street address, city, state, and zip code within a account owner object. That means you need not have to separately create those objects again. Let me go back here. You're not creating all those properties again, so you put all those in a logical object called address. Okay, so that means even this composition is supported in Hibernate. Okay, so that's how we are talking about. So can be made up of this first entity is nothing but a first class citizen, and it can be made up of multiple components like this address, and here you can say like contact. You can create something like a contact where you can have his home phone and a cell phone and stuff like that. So it's made up of multiple components. Then can be related or associated to other entities. So you can relate this account owner to something else using our one to many and all that yesterday we saw, right? So entity is nothing but it's a first class citizen, and it has its own class name, and it is mapped to its own table, like a same table where it can have multiple components. That's what is an entity. And now let's look at an example of entity component, just like how we saw just now. Account owner is an entity and can live on its own, has its valid ID. That means valid ID is account owner ID. That means it has its own primary key. Okay, its own primary key. Then we are talking about address. Address is a component of account owner, non-existent without account owner. So this is composition. Like this representation is called composition. I mean, if it is tightly put in like this, address has no meaning if it is not associated to account owner. That means address should die along with account owner. Address should be created along with account owner. Okay. Without that, it cannot exist. Fine. Let's move on. Using components. So determine your domain model, which objects are best suited to the component. Like create your database tables, model your components accordingly within the entity. So in our we modeled the database tables, and we looked at the account owner object. Logically, we thought, oh, all these fields can go to address, and we put it in a logical object, right? So that is what is called a component. And create your Java class, one for each entity and one for each component. Set up your components within the entity class. So we set up our components in the entity class. Write a Hibernate mapping file for the entity using the embedded component tag. So let's look at account owner.html.xml. Okay, see here. So if we have it here, okay, these are all the properties. If you look at only the address thing, it has component tag address, parent, how it is associated. It is associated to an account owner, and it has a street address, city, state, zip code, okay, and all that stuff. So this is represented as a component within a component tag or a component annotation. If you don't want to use XMLs, you just say component @component, something like that. Okay. So we got to import a Hibernate 4, then you will see all the annotations. But what I'm trying to say is, if it is annotation or XML, doesn't matter, but learn the concept. Then, so this is component, and within that you declare the in the HPM.xml the component and all the properties. Let's go back to our PDF. So set up your components within the entity. So write the Hibernate mapping file for the entity using the embedded component tag within it to identify the component class. So we identified our component class. If you look at it, it's our address class, right? Okay, it's our address class. It has account owner, ID, property name, and then component is this and all. Okay, so this is the component we are referring to. Just now we saw, right? Then nested components. You can have one or more components, right? So component address has nested component zip code. We just saw that, right? So here, let's go to address, and within that we have another component called zip code. That means zip and +4. Okay. So you can have nested components also. It means account owner has address, address has zip code. Okay. Mapping nested components. We just specify it within the component. So it is all supported. Collections of components. So if you have collection of components, you are going to just say, okay, whether it's a list or a set or a bag or whatever you want. And then what is the key column ID within that? Okay. So list, it is like a account has list of account owners. Fine. From that, you also specify, okay, you want to know address. Okay. Address, street address is with this query. Let me actually go to that example, probably that makes more sense. Let me go to account object. First, let's look at the objects before looking at the HPM.xml. Okay. Now let's talk about which one they are referring to, right? So they are referring to account object, And within account object, do you see account owner addresses? I don't see it. Let's see. Okay, so it has a list of account owners. Maybe they are referring to something else, right? I don't see this file. Like, let me see. Account doesn't have anything. Yeah, these are all various other things. It's even the registration. Yeah, that's fine. Let's look at it here. So what they are referring to is if it is a collection of account owner addresses that you have to maintain, all you're going to do is we're going to say composite element class address, okay, class address, and then you're going to give property name street address, and you're going to give the query like you want to know street address of the account owner with a certain ID, and you want to know city, you want to know state. So this becomes the composite element. That means you have list of account owner addresses, okay, and within that list each and every property is a address, and you are identifying each and every property of the address like street address, city, state. Okay, I think I know where this example is. Let me actually go back. Probably it's in yesterday's sample. Let me see. Yeah, here. So let's go back to this account object. Look at this account object, not the today's one. Let's see. So we have an account. It has a list of addresses. So that means it's a component of addresses that we have. So how are they populating those addresses? Let's see in the XML file. So what they are trying to do is, okay, so I have the account object, and within the account object I have all the other properties and also account owner addresses. And here all we are trying to do is, okay, I know the account owner name. Okay, if I know the account owner ID, I need to know his street address. If I know the account owner's ID, I need to know his city, I need to know his state and all that stuff. And within that I need to know his zip code and all that. Okay, so if you know the account owner ID, you're going to get a bunch of data associated to each of these people. Okay, and you're constructing an account object. So let's execute this example, and probably that's when you will understand it, like how it is behaving and all that. Let's see if it is fetching the addresses also or not. I'll just execute one get account. I don't want anything else, provided if we have the accounts created already. I think we're creating it here. If it is not there, that's okay. So let me just run this here. Okay, schema is up to date. Created the accounts. Yes. So let's see, once it has been invoked, what do we have here, right? Let's see. Are you guys able to see my yellow pop-up here? Um, So if you are able to see that, I just want to show account owner addresses within that. Okay, and what it has is all empty. See here, I don't really have any data. Like if you look at the account owner set, it didn't have anything, any data. I because if you go to my table here, so if you see here, I have last name, first name. So I have this city, state, and zip code, right? Some of the something from here should be fetched out, but it is not. Let's see why. So it is looking at account ID 32. Okay, so we are getting the account, not the account owner, right? So let's go back to account. Let's see account. Account has 32. In that account 32, let's see account owner table. Okay, where account ID equals to 32. Okay, once you get that, there is nothing, right? There is no account owner created for it. That's why we are not getting any data back. See here about the addresses, but this test case is a little different. That's why. Okay, let me see the one with the address stuff. I think we saw one yesterday. Let's see. Is update balance, this is delete account, test many account owners. Yeah, so this is where actually we are creating an account owner and then mapping account owner to account and all that stuff, right? So probably here we should be able to see, let's see here. So we should be able to see an account owner, creating an account owner, and okay, we are building an account owner. So this is where we are building an account owner, and are we mapping it to an account? Yeah. So I think this is the test case I should have executed to show to you guys how it is mapping. Okay, let me go here. Okay, so we are building a savings account, two savings account. One has one owner and the other one has two owners. And we saved both. We committed. That's when it persists. Okay. So now let's look at our table here. Nothing is there yet, but here. So it created two accounts, and it created here two account owners. Okay. Let's see the data. So here, what we're trying to fetch is account owner 1. So when you fetch account owner 1, so it has list of accounts, and it also has the address component set. So all we are trying to see is how the address component is getting set. Okay. So address object is already mapped because you put it as a component. Okay, because you put it as a component. And let's also see. Oh, it deleted also. I shouldn't have executed entirely. Oh, whatever has been created is deleted also. So this is the thing. Like we executed it yesterday. Like look at these two accounts, and then it is mapped to accounts. We saw all this, right? You guys know this already. Like account owner is associated to an account and all that. The same way, let me actually show something else as well. Create multiple account transactions, account inheritance. Okay. So all I'm trying to do is, given an account, how it is fetching, if you have address and list of account owners and all that, how it is actually giving you, within that collection for, like if you have more than one address type, how it is actually setting all the data, uh, like this one. Let's go to account object. So all I need is, if I fetch an object, I need to get a list of account addresses, and it can be one or more. Okay, it can be one or more. The reason being, just like this, the query should be executed like this. Select star from account where account ID equals to 15 if I execute, say, suppose. Okay, for account ID 15, I have list of account owners, which are 1 and 2, and for each account owner, if I go to account owner this one, I have these two people, and each of these will have a address. Okay, each of these will have an address. So that's the thing I want to show. I'm just trying to see which test case can actually display that properly to you guys. That's the thing I'm trying to actually execute. We looked at it yesterday, but not in this perspective. That's the reason I'm actually executing bunch of test cases here. One second. So this is not required for us in this situation. And here, create multiple account transactions. We don't need account transactions related stuff. Create multiple e-bills. This also is not required. Okay, test many to many account owners. This is what we just executed. Delete account. I don't want to delete the account. I want to update the balance. I will not execute this. Test get account and create account. Okay. Let's see. I don't know why it did not create schema. Let me actually drop everything and recreate. Yeah, update should be fine. Let me actually create. So that will actually drop and recreate. Okay. So it created and deleted. So let's see the each and every table. So nothing has data. So we are good. Let's start from the clean slate and see why account owner thing is not working. Okay, as desired. So we don't have anything right now. We'll go to this one. Okay. Okay. So I created insert into account owner. Account owners are created. Accounts are created. Okay. So accounts are getting created. Okay, accounts are getting created, these two, and let's see if it created anything in this. Yeah, this is what I wanted. See here, so account owner also got created. This is the join table. So now if I fetch an account, we'll get the account owner and their addresses also. So let's look at that closely. Okay, so now account owner ID. So I fetched an account owner. When I fetch an account owner, he has all the address that you know already, because account and owner is associated to an address, and we are mapping the component properly. And then we fetched account owner 2, so he has two different accounts associated. That is also fine. And here we'll see addresses mapped. Fine. This is at the account owner level. We know account owner object itself has the address and everything, so it will come with the component tag. All I want to show is when you fetch account, how it is getting that. Okay, so here if you look at this account object, see here account object, within that you have account owner addresses, and within that account owner addresses you will see city, state, and zip code. See here, like account owner addresses is a collection, and if you want to see the values of the collection, generally you go to key, I think key. Okay, owner is this, role is this. So it's like a two-string value. When you focus on this, what are all the values associated within it will be displayed like this. I just want to show. Okay, this is a set. Within that you will have a bunch of values like this. Yeah, so see here, so this is the okay value. See the object, it has these values. See, so everything is set. Okay, all the values that you are looking for in each and every like collection. So this is the set may have one or more values, but in this case we fetched account ID 1, right? Account ID 1, the account ID here is what, 1. If you go back here, account owner has only one account owner, right? So that's why you got only one address out. But account 2 has two owners, so you need to get the addresses of both the people. Let's see here, that's why collection is handy. It can have one or more. See here, it should have two values. Let's see if we got two values here or not. Account owner addresses. Okay, account owner addresses, and then here I'm just looking for a snapshot. See here, we have two. Both the addresses came out, right? Both the addresses. Looking at, did we create a same address for both? Let's here go to account owners. Yeah, looks like it's the same address for both. That's why we could not distinguish. But that's fine. We got two addresses. If you look at the address owner sizes, get account owner addresses, its size is 2. For account 2, but why will it be 2 for the account owner 1, right? Why will it be 2 for account owner 1? Account owner 1 should have only one address, isn't it? Let's see account ID. Account ID is 1, and for that, who is the account owner? Let's go look at it in the account owner account ID. So for account ID 1, we have how many account owners? Only one. And look at it as account owner ID 1 here, right? So take that and go to account owner. 1 has, it should have only one address, right? Why it has 2? Let's see. We are asserting on having it as 2. Let's see, what is this assert equals doing? Expected is 1. And what is this third argument? Let's see. Maybe I'm not reading this one correctly. Like, if we have 3 arguments, what is it called? Like, we have assert equals 3 arguments here. 1 account addresses and 2. What is this 2 called? Let's see. All integers. What is it for all integers? There are only 2 here. 3 only for these guys. Okay, so let me see the size of this one. Yeah, it is just 1. So it is just mapping these two. And what is this third argument? I've never used the third one. Let me see. Yeah, I'm trying to understand as well. Assert equals. Interesting. So what is this API? Is in typical JUnit. Okay. So that's a deprecated class. That's why. So you can go look at it in the API. Let's see. Assert class. Okay. Within the assert class, we have assert with 3 arguments. And what is that assert equals with 3 arguments is called either it can be a message, expected, actual, and delta. Assert 2 doubles. Okay, let's see what is this delta thing talking about. Okay, so asserts the 2 doubles are floats, but we have integers. That's okay. Are equal to within a positive delta. If they are not, an assert error is okay. So some random number we can give here. It's like a delta. Okay. That doesn't matter whether we give this or not. Okay. Okay. So it's obsolete. I just have to rerun it. That's all. That's the only difference. But you guys can see one more time if you want. Oh, I didn't have a debug here. Ah, that's crazy. Okay. So account owner should have only one address. Only one address is there. And account owner should have 2. Account owner 2 also has only one. Okay. Account owner should have 2 addresses, right? How many it has? Account owner 2. Let's see whether I am looking at it right or not. We have 2 account owners. Okay. Account owner 2 has two account owners, right? Account 2 has two account owners. When you have two account owners, let's execute this query. So this is what it is executing and fetching the data, right? Let's execute the same query. Why we are getting a invalid value? Account 2. So let's see account owner. So behaving differently. Account ID 2 has only one here. See here. Account owner ID 1 has two entries. I'm not following why it is doing all this to us. Okay. See here. We have created an account 9, say suppose 8 and 9 in this case. Okay. 9 has account ID 9. Look at account ID 9. How many owners it has? Two owners. Okay. Two owners. And each of these owners are associated to a record here, right? Look at account 2 and 3. There is no entry 3 here. Did you guys see that? Did you guys see? There is no account owner ID 3. But in account owner, we had an account owner ID 3. That's why it's not picking up. Okay. It's all just because I executed multiple times, it's getting confused, I think. All I want to do is delete all the data from account. Okay. It says cannot truncate the table with a foreign reference. Okay. So I'm going to delete from account. I'll come from bottom. That means all the references. Okay. To delete it. Delete from account owner. Okay. Deleted. Delete from account owner. Delete from account. Okay. I delete all the data now. So everything is clean. And let's start from this execution of this one now. All I care about is this. Okay. So all I care about is the account addresses. Let's look at the data before doing that. So I have two accounts. Look at account owner. So now account 1 has only one account owner. Account 2 has two account owners, which is good, which is what we expect. And let's see. And whether 1, 2, and 3 exist in the account owner or not. See, this is the thing. Account owner 3 doesn't exist in the account owner ID. The reason being, can one of you tell me what is the problem? So there is no account owner ID 3 here. That's why, though how many times you execute, like this is the problem here. Account owner ID it is looking for is 3. Like this is 3. Account owner ID 1 and account owner ID 2. Okay. I think we are fine. No problem there. I think we are fine. No problem there. All I'm trying to show is account owner 2 should have 2 addresses. Account 2. Let's see if we can achieve that in here. Okay. Got the account 2. So account owner 2. So account 2 has 2 owners. Let's see. What is it? Why it's failing? Oh, why it's failing? Yeah. It says expected 5 but was actually 6. Sorry folks, this recreating is actually driving me nuts here. The schema multiple times creating me. So I put it as create or auto. Let me put it as auto. Okay. Let me put it as auto. So let me see. If I rename it. Okay. Let me actually drop again. This run should clear everything. Okay. So let's see the data. Okay, everything is clean. Let's execute this. So you have the accounts. You have everything in there. And now let's look at account owner 1. So we have no problem here. While fetching account owner 2. Account owner 1 has only 1. And I want to show the size of account owner 2. Still this one, right? Account owner 2 should be 2, right? Why is it saying that is the problem here. Expected is 2 but was 1. So why it's not fetching? Everything seems to be fine here so far. You have account ID 2. Account ID here is what? 2. You pass 2, so you should get 2. Okay, you should get 2. And account owner here is this one. So till yesterday all these this test case worked for us, right? We saw this yesterday. And the only thing I changed when it was failing assert was this one. Okay? We did not have any failure yesterday on this one. So that's why they put 2 probably. Like delta max can be 2. And that's why we could get past it probably. Let's see. But nevertheless, I want to show it fetching two addresses. That's why I was trying multiple times. Yeah, now it was. See. So that means that delta 2 is saving us. That's why we could not identify this problem yesterday. Okay. So let's see. Account owner 1 has get addresses. And this addresses is a set. Do you know why it's not giving 2 values? That is because set doesn't allow duplicates. And we have the same address for both the guys. Okay. We have same address for both the people. Like we're just changing this one, right? We're not changing anything else. So build account owner, right? So okay, I'm just putting in some time. That's when it can be distinct. All I'm trying to make is name is different or something is different. Okay. So this one we are okay, but here, right? So account 2 still says 1. Why account owner addresses? It is a set to string not the this one to string. We got to look at address to string. I thought, hmm, that's the problem. Address, I should have made unique. Address equals is failing. That's why it is actually giving only one object for us. Um, Building account owner. Instead of doing it for name, I can do it for the city. Okay. Let's okay. So let's fetch this and fetch this one. Oh, 2. Do you see it now? So it's because of address not being unique. Like you got to be really careful when you're using objects, right? You got to see how the dot equals method is overridden. Based on that, you got to have the data where the dot equals method is overridden. You got to make it unique. That's why, though we were expecting 2 objects, it did not give 2 objects because both account owners have the same address. Okay, both account owners have the same address, so that's why it is a set. When it is a set, it doesn't allow duplicates, and so it was giving only 1, though we were expecting 2. All I did was I made the street address unique. If you look at this one now, our street addresses will be funny, like okay, 123 first street, 4th street, but you have time in milliseconds appended to it, so which made it unique. How I know I got to make one of these unique is because by looking at address object dot equals method. So it is comparing city, state, street address, zip. So I could have made one of these unique to say equals false, and set would have added 2 objects. Okay. So in that I chose only street address. You can choose city to be um, unique. You can modify that and you can see. So all I want to show you is components can be retrieved even within the a collection. Okay, that means account has list of account owners, and account owners can have this, or accounts have list of addresses, and you can fetch it that way either. So it is mapped as component. If you look at our example where we started as component, like account has set of account owner addresses, which is a component. You can put like composite element and specify address, and you can give the query like however you want to fetch it. Okay, account owner ID, fetch me the street address. Account owner ID, fetch me the city. Given an account ID, fetch me the state. So you can construct your address object however you want with the properties you are setting, and you can retrieve it. Okay, So if you look at our object which has been constructed right now, it should just have street, city, and state, because we are looking for only those values. We are not looking for zip code. Okay, we are not looking for zip code. So that value should not come back. Okay, because in our mapping we were looking for only those three values. Go back here. So you have the set. Go to the set and see values within the set. Two values is right. In both of these, object has zip code also. Okay, that's good. Savings account, role, list of set of account addresses. Okay, see here. Okay, okay. So it is fetching even the zip code object. Okay. Why I was thinking it will not is because, okay. So this is only these three, and how will it know to fetch the zip code also, right? How will it know to fetch the zip code also? Let's look at our mapping file here. Account dot hbm dot mapping, right? So let's look at this one. Yeah, because this guy was getting nested object also, that's why it is getting the zip code. Otherwise, if it was like this as in the slide, it will not fetch it. Okay, so are you guys with me so far? Like, did you see what I was trying and understood what I was trying to demonstrate? Like, if your composite element is just this, you wouldn't have got the zip code, because because the component had nested also zip code. That's why zip code was displayed. So that's why I was looking at this one and saying like, oh, you will not get the zip code. But because we had the nested component also configured, we are getting the zip code as well. Okay. So then, any questions so far? Did you see like what I tried, how I tried to make it unique and all that? Are you guys with me? Can you hear me actually?
Yes. Yes, Ravi.
Okay. So did you follow what I was trying to demonstrate, and how the components are mapped? What is a component? Or any questions so far? That's a no or yes? No questions? Okay. Okay. Component as entity ID. Okay. So done with or without a separate Java class. So if you have if using Java class, must implement comparable and serializable interface, must define a class attribute in the mapping file. So if a composite key contains identifiers from associations like ID. So before even all this, let's look at all this theory apart. Let's look at how we configured our component here, right? Go to um, account.html.xml. Here, this will be simplest, I think. Here, uh, I think this should be simplest. Okay. So what we're trying to do here, we're specifying class, name of the class, component tag, name of the address, giving the parent ID. That's all, and any other components that it has. So here we are saying like component as entity ID. So done with or without a separating Java class, that itself is called a component. If using Java class, must implement, if we are looking at our address object. So generally, why we ask to people to implement comparable and serializable is to identify the comparison. If you were to sort it or anything, you can use this comparable or comparator interface. And serializable interface, because this is the data that you want to persist or you want to execute in multiple JVMs. You want to make it implement serializable, and must define the class attribute in the mapping file. So that is what we saw just now. Like anything that we want to use, you have to specify it in the mapping file, which is okay. Now, if composite key contains identifiers from associations, like, okay, set the ID value when you set the corresponding association on the main object, like one to many and all that. So you want to specify all the relationships there itself, and set insert equal to false and update equal to false on the associations on the main object. So all they are trying to say is you can use these components even during the one to many and many to one mappings as well, just like how we did between account and account owner. Within account owner, you can have the components and all that. Okay. So let's see here. They are giving an example of a component. eBill uses eBill ID component as primary key. Okay. See here. eBill. Okay. Let me show that example. Go to eBill. Okay. Here we are saying eBill ID. It's the primary key actually for the eBill object. Okay. So here eBill uses eBill ID component as the, okay, it's a little different than what I'm explaining. Okay. Okay, so let's see it here. So eBill object is there, right? You have a primary key, okay, eBill ID, and if it is a composite primary key, you cannot have just one ID as a primary key, right? You have to have more than one column as a primary key. So all they are trying to do is within eBill ID, combination of these three is a primary key. Okay, so now we are talking about component as an entity ID. That means we are creating a component, okay, to map one or more columns as composite primary key. Okay, so that is called component ID. Okay, how to configure this? Example, eBill uses eBill ID. eBill ID is a primary composite primary key combination of account ID, uh, eBiller ID, and due date. And to do component as entity ID, what we need to do, we must implement comparable and serializable, because comparable is implemented for what? Because we want to compare or check the two objects that have been passed are equal or not. Okay. How do we check that? Here the implementation is, it is checking the due date. Okay, the due date of the current e-bill and the due date of the passed in e-bill are same, then it is called current. It's called the same. Okay, that's why anything that you have used as e-bill ID should implement comparable and serializable, because it has to be working on multiple JVMs also. Okay, and must define a class attribute. Okay, so where are we defining the class attribute? Let's go to ebiller.hpm.xml. This is one of our entities, right? It's ebiller or ebill.hpm.xml. Okay, fine. Here let's take a look. ebill has a composite primary key. How are we specifying it? Composite ID, ebill ID, and we are specifying the key attributes which are part of it. That's it. This composite entity, name of it, and then give the name of the object itself. That's it. That's when you can configure that. Configure whatever you want. Okay, fine. Okay, then if composite key contains identifiers from associations, set ID value when you set the corresponding association on that. main object. So if composite key contains identifiers from associations, let's see what it is. Okay, so identifiers from associations, see here. Here the identifier is from account ID. Instead you had some other relationship ID in there. uh, See, must have an insert equal to false and or as part of, see here, must have insert equal to false, update equal to false, because IDs for the objects are part of the composite key. Okay, so e-biller ID and account ID. Okay, these two are part of primary key, right? You are not supposed to be updating primary key at any point of time, or a foreign key of other tables. So that's why we are making sure we set these two. Okay, so this is what they are talking about here. So set insert equal to false and update equal to false on the association on the main object. That means set ID when you set the corresponding association on the main object. So here ID is there. You considered those IDs. When you consider those IDs which are part of many to one, or that means which are part of any relationships or associations within this object, like e-bill is associated to e-biller, e-bill is associated to an account. When there are associations like this and those IDs are part of your composite primary key, okay, those IDs are part of your composite primary key, then you got to explicitly set insert equal to false and update equal to false. So any modifications that happen will not impact any of those associations. Okay, fine. Then see, example, eBill uses eBill ID component as primary key. In eBill entry called class eBill ID, values are set as appropriate setters are called. Okay, so let's look at eBill.java. So eBill.java, eBill ID. How are we creating eBill ID? We have a setter. Okay, and how the e-biller is being set. Let's look at set e-biller. Okay, so either you take e-biller and set the e-biller ID. Need this to set the composite primary key, because you need to know the e-biller ID, right? Do you see it here? E-biller ID is required to create a e-bill. You need an account ID, e-biller ID, and the due date. Otherwise, you cannot create a e-bill object. So that's what they are talking about. Just the constructor kind of stuff they are talking. Component as entity ID. Just now we saw this. So must have insert equal to false and update equal to false, because IDs for the objects are part of the composite key. Okay, so you should not be updating anything. Using a component as an entity ID and not using a separate class to represent it can be troublesome. You cannot simply pass in attributes which make up the key into a session.get. So that's why you cannot do this if you have more than one key. That's why what we do is session.get, we say email. So if let's go see the test case here, then probably you will get a more feel of it. Yeah. E-bill is there, right? In e-bill we created our e-biller, and when we saved the e-bill, okay, and to fetch the e-bill, say for example, to fetch the e-bill here, get e-bill is there, right? So when you have get e-bill, e-bill ID is what? It's an entity, right? Let's go see how we are calling our get method. We're saying session.get e-bill ID. Just like even if you have an integer, you call the same. Even if you have a, like if you know the primary key, you'll call the same. If the primary key is an object also, you will call the same. All they are trying to specify in this one is, you cannot say, like if you have more than one key as a primary key, you cannot simply keep on extending this guy like int x, int y and all that. So that's why we create an entity object and still call session.get and pass the entity of pass the entity that will accept, okay, that will accept a serializable object, okay, that will accept a serializable object. It can be simple primary key with an integer, or it can be a custom class like our ebill id, which has more than one column. So that means it is taking care of all these, while you pass it like one object. So it is trying to say select star from ebill, where ebill id, it's not just the id. What it says is where where account id equals this, e-biller id equals to something that we pass, and due date equals to something that we pass. So that means it is taking care of all that within a within an object. It's like a wrapper. Like what we are trying to do is, oh, instead of carrying 10 different things and saying them as primary key, we are putting them everything in one object. We are putting everything in one object, and we are saying, oh, this is my primary key. So Hibernate internally takes care of how to iterate, how to look for each of these properties, and give you back the values result set. Okay. So need to write separate Hibernate querying to bring back the object. So so we just say like session.get ebill, and we say like this kind of stuff is not supported by session. So that's why we just say ebill and ebill id. It will take care of everything. Okay. Then we're looking at inheritance now. So all is well, from the beginning of the session till now, we were looking at composition. What is composition? Whole part relationship. And now like address can be a component of a account owner. Like I'm an account owner. If you want to know address details and all that stuff about me, you can just get the component of my, like, okay, account owner dot get address, and you can get everything. So this is called component composition. And now we are looking at inheritance. Okay, what is inheritance? It's an easy relationship, right? So allows for logical affiliation of classes with common state or behavior, commonly referred to as an easy relationship. A cat is an animal, we know all this, right? A dog is an animal. So that's how we started our inheritance with. Polymorphism is like dynamic realization of subclass behavior while treating the object as an instance of its superclass. So this is polymorphism. Like animal, we say cat extends animal, dog extends animal. So we know this, right? Previously we saw in our inheritance class, and we say animal equals to new cat, or animal equals to new dog, right? Either of these. And when you actually say animal dot speak during runtime, it will look at whether it is a cat object or a dog object, and it will invoke either speak from the cat or speak from the dog object, right? We know all this. Like see here, form list of animals, and we are iterating through the list of animals, and we are saying like, okay, some animals are speak, so it can come as this one or wolf, like depending on the type of object. Okay. Inheritance realization, easy to do in an object oriented language. So use extends or implements keyword. We know this, right? Either we can extend in a class or implement an interface. Depending, both of those are called inheritance. So not so easy to do in a relational database. Tables do not extend from each other. Okay, so in a relational database, no two table, there is no concept called extension, and it is similar to procedure oriented, right? So there is nothing like one table extends other table. There is nothing like that. So not so easy to do in a relational table. So part of the impedance mismatch problem. What is impedance mismatch problem? In the first class of Hibernate, we talked about it. That's it. Hibernate is designed in terms of object-oriented world, and it knows only about the objects inheritance and polymorphism and all this stuff. Whereas tables are designed for, okay, they can be modular, they can be relation. There can be relations like joins. You can save data in such a way that it need not be redundant and all that stuff. So it is designed for something else like storing the data and all that. So these two are designed for two different purposes. Okay, one is to make it modular and all that, other one is to make it easy to store, and um, the kind of problems that it wants to address are like how to efficiently fetch the data and all that. Okay, so these are like two different problems, that two different things. impedance mismatch meaning designed for two different objectives. Okay, and now how to get around it? Now we are trying to bridge the gap between object oriented and relational using OR mapping, right? So that's why, how do we get around this? Like, we know inheritance, polymorphism and all. How can we adapt it in Hibernate? That's the thing we are trying to see. So how do we get around this? Four approaches through Hibernate. Hibernate implicit polymorphism, and creating one table per concrete class. Like if you have a checking account, savings account and an account, so you're going to create one table for like checking account, one for savings account. Sounds weird, but one table for each contract class, or table per hierarchy, that means super class or subclass, table per subclass. Okay, so that means there can be 10 different concrete classes, but there can be one subclass. Like within that subclass you can distinguish between various things. So these are the various approaches they came up with, either through polymorphism, table per concrete class, table per class hierarchy, or table per subclass. Okay, let's see what are all these. Okay, modeling inheritance. So determine your domain model. So what objects have hierarchical relationships? So as I said yesterday, you should really understand your domain before even doing either creating a table or before creating your Java objects. Okay, so you have to understand the relationships, identify the entities and all that stuff. Then choose your inheritance strategy. Which of these inheritance strategies suits? To know that, you need to know what are these inheritance strategies. We'll talk about it in a bit. Okay, create your database tables based on the chosen strategy. Code your Java objects using extends or implements, and write your Hibernate mapping files using the appropriate subclasses. That's the approach. So now, what is this implicit how polymorphism is all about? Database, one database table per concrete class. So what does that mean? Okay, so Hibernate mapping files. Mm, Separate mapping files for each and inherited class, like normal, including any inherited properties. Default behavior. Out of the box, Hibernate will automatically recognize any Java inheritance associations. Let's see how. Implicit polymorphy. One table per concrete class. So what are we trying to do here? We have a checking account. We have a savings account. Okay. We have an account as an abstract class. We saw this example already. So nullable. Okay. So we created some all columns nullable no. That means they all should have values. Okay. So we have a checking account object and savings account object separately. So it has check style and it has interest rate. Okay. So two different tables. If you look at our sample that we looked at yesterday, we created only one table. We don't have two tables for account. Do you see that? We have only one table for account. And how did we distinguish account type? Using a discriminator column. Remember that? While discriminating, we said, oh, if you have interest rate, then it is a savings account. If you have check style, that means it's a savings checking account. That's how we were populating. But instead, Hibernate is coming up with something called one table per concrete class. So that means you have two tables. Okay, two tables. And looking at it on top of your mind, what you can expect could be a drawback, redundancy, right? Like you're actually like these two are same. Only thing that changes is these values. But let's see. Let me not prejudice you guys with my understanding. Let's see. Checking account. You're creating a just property creation date. So if you have two tables, you have to create two HBM.xml files. You have to create two checking like one object checking account.java and the other object savings account.java, which has a primary key and everything. Okay. Now here you put savings account and all that. So advantages of it: get it free. Hibernate automatically scans classes on startup. No additional configuration required. Not a lot of nullable values. Queries against individual types are fast and simple. Disadvantages: make handling relationships difficult. One-to-many relationships typically require a foreign key. That means account and account owner, and account owner and account relationship Doesn't care about whether it's a checking account that you are relating it with or savings account that you are relating it with. It's the relationship between account and the account owner. In that case, the relationship will be, we got to consider both checking account and savings account, which may be a little bit cumbersome in design, right? So polymorphic queries are process intensive. For queries against superclass, Hibernate executes multiple queries because it has to know whether you are giving me it a checking account or a savings account. It has to determine during runtime. That's why you will have a lot of queries getting created. And database schema evaluation more complex. Need to add same columns to multiple tables. This was my point. Like we are actually making it redundant, right? So this was my point as well. Like need to add same column into multiple tables. Integrity constraints might have to span multiple tables, which is like whenever you're duplicating something, there's a higher chance that you're actually introducing a bug because it's tough to maintain. Okay. Table per concrete class. Okay. So this one was, we were creating one per concrete class, right? So one database table. Okay. So this one was what? Table per each subclass, right? Did you see this? What did we say here? Let me go back. Sorry. So okay, table per concrete class, table per class hierarchy, table per subclass. Okay, let's remember this and let's go down. Okay. Okay. So what we are trying to do now? Database, one database table per concrete class. Hibernate mapping is single mapping file based on superclass. Includes union subclass definitions for the inherited class. Let's see this. So one table per concrete class. So what we are trying to do here, we have a checking and a savings account. And how are we mapping it? Class, account, and ID. Creation is this. Union, subclass is a savings account, and union checking account is property. Okay. So that means this is how you're going to have your account object. If you have table per concrete class, you're going to have union subclass as an element which tells it, okay, either use this or this. That's why Hibernate had to end up querying a lot. Like, okay, select start from this savings account, whether it has interest rate. Oh, it doesn't have an interest rate. Then it's a checking account. So it identifies it as like, oh, it's a checking account, and then maps it to into an account object. So it's like a little bit cumbersome and extra queries. That was their point. Okay. Then table per concrete class. Advantage is shared mapping of common elements, not a lot of nullable columns. Queries against individual types are fast and simple. Less SQL statements generated with the use of union. So the problem of um, the problem of duplication of data or duplicate efforts Hibernate has to do is being taken care by union subclass is what they are talking about. Okay. Before this, let's see some examples and then we talk about this concept. Okay. I think we may get overrun without me mentioning each of those. Okay. Without mentioning sample. Okay. Okay. Let me go back here. Okay. Sorry about. Okay. Okay. Let's look at account. So what are we talking about here? Here we had this step. So I'm just making sure I have examples for all of this. So what we are talking about here so far was not one table for each. It is one table for each concrete class, right? One table for each concrete class. Let's see that. So one table for each concrete class. Uh, I don't think I have an example for that. I have the discriminator column example only. I have the discriminator column example only. Okay, let's see it here one more time. So all we were talking about here is this part. You guys were clear, right? Like you have only one table, okay? Savings account and checking account. So sorry, you have two tables, one table per concrete class. That means you are creating one table for checking account and one for savings account. Abstract class is account. So this part we were clear. Like we created two objects, and when we created two objects, it has to do the properties and it can be redundant. Okay, and it can be redundant in both, and it brings in a lot of maintenance effort. That we were clear, right? Um, then disadvantages are making handling relationship difficult, that we saw, and database schema evolution more complex. Okay, so here till here we are all good. Okay, then database table, one database table per concrete class is fine. Okay, here what we are saying is okay, um, single mapping file based on the superclass. And what we are trying to do here, union subclass definition for inherited classes. So there is one other approach. Okay, you can have two different concrete tables. One is checking account, another one is savings account. But you can use a union subclass definition for both the inherited classes. So all we are trying to do here is, yeah, okay, you have a checking account, you have a savings account table. Okay, everything is similar to previous approach. All we are trying to do here is we are actually trying to introduce something called union subclass. What we are trying to do here, okay, you are specifying, okay, this is an abstract class in the mapping, and this is my one concrete class, and this is my another concrete class. Okay, so that means you are bringing in something called a new element, union subclass, that actually is a concrete class. That means an account object can be either a savings account object or a checking account object. So all we are trying to do is we are trying to union the behavior into the subclass, into the superclass. Okay, we are trying to bring in the union of subclass behavior to the superclass. And what we are trying to do here with this approach, shared mapping of common elements. So that way, hibernate wise, you need not have to maintain two different hbm.xml files. You can still maintain only one XML file and not a lot of null columns. So you need not bring in null columns, a lot of null columns, because you can create an account table, and you can create a like you need not create an account table. Um, like you can separate out. Like you need not have if you shared a same table, what all the features that are part of a checking account will be null for savings account object, and what all are available for savings account will be null for checking account. So if you maintain them in one table, that is the problem. But here with this, you have two different tables, so you don't have a lot of null columns, which is true even in the previous approach where we had two different hbm.xml files, right? Now here, queries against individual types are fast and simple. That is the same advantage as before. Less SQL statements generated with the use of union for polymorphic queries. That means this union subclass is making Hibernate aware that okay, a particular account object can be either this or that. So internally, it's actually making it fire less queries compared to the previous approach. Like previous approach, here it has to do, okay, given an account owner ID, whether this is a checking account or a savings account, constantly it has to fire multiple queries constantly to determine, because these are not part of a same hpm.xml file. These are part of two different hpm.xml files, and Hibernate thinks these are two different entities, and it has to constantly determine, given an owner ID, oh, he has checking accounts or he has savings accounts. Oh, okay, if he has checking account, then it has to handle it different way. Savings account, it has to handle it different way. That handling different is still there, but it need not have to fire multiple queries because of the use of union subclass element. Okay, then disadvantages still have the difficulty with relationships, because we don't know how to manage it with the associations, and database schema evaluation still more complex because we are maintaining two different tables. Okay, then